Clayton. Which math class are you taking right now?
I am taking Math 1C at
Yeah.
Dianza.
Oh, who was the professor you took Math 1A?
1A.
Uh-huh.
I forgot her name, but do you want me to look it up?
It's all good. It's all good. Can you
Okay.
tell us about your experience when you're studying derivatives and using a chain rule specifically?
So, when I was studying derivatives, it was very unusual because I wasn't used to it. But essentially, how I understand the chain rule is that when you multiply one number by another, instead of just multiplying their derivatives, you instead multiply the derivative of the first term times the non-derivative of the second term, and then you multiply by the derivative of the second term times the non-derivative of the first term. And essentially that's how you get the derivative of the two combined.
Well, what if it becomes like a multiple derivatives, like second derivatives and third derivatives?
If it becomes second and third derivatives, what do you mean by that?
Like some problems we need to find like second derivatives, right? How does it?
Okay, so when the long way to do it, I'm sure there's a shorter way, but you can take the derivative that you got from the first run through and basically do it again. You repeat the same process with the second derivative. It's like a multiple step process, but it's been a long time since I've done it, so I'm not really sure.
From my understanding of derivatives and using chain rule in derivatives, so basically it's peeling the onion, right? Onion has so many layers, so
Yeah.
one layer of onion is chain rule f prime of g of x times g prime of x.
Yeah.
That's I believe like how chain rule works in as a onion. Every onion layer you peel off, you gotta use like inside of the rule. For example, x to the 2 and how can I explain it? X to the 2 over like x to the 2, like a double bracket,
Yeah.
double exponent, right?
I see.
You see what I mean? Like I don't know how to say in like English, but it's like double derivatives. Sorry, double exponents, and again and again. In that case, I think my analogy of explaining with onion will be much more clear. What do you think about that?
I think your explanation is pretty valid in the sense that there could be many layers to the derivation that are not typical if you're just deriving one time. So I think that's a valid explanation.
So how would you explain it to like fifth grader if you were teaching to your, fifth grader brothers?
If I was explaining it to a fifth grader, I would say when you're taking multiple derivatives, you need to keep track and lay things out in a very particular way. And so the way you should do that is you can essentially keep taking derivatives of that same derivative following a specific format. And essentially, yes, it's as basic as multiplication, but there are just a few intermediate steps.
So how was the 1B?
1B?
1B, yeah.
1B was challenging because there was a lot of memorization involved.
Oh, did you guys use the chain rule in 1B?
Did we use a chain rule in 1B? I believe so, yes.
How did they reflect, like, from what I heard from professor, like, 1B is essentially antiderivative stuff.
Yeah. So the way antiderivatives work is it's just the opposite of a derivative. So there's a whole new methodology into how you do antiderivatives. But essentially the gist of it is it's the same as a derivative. So for example, if you have 2 to the x squared dx, it would become, oh, that's a bad example. Let me do x squared. Antiderivative of x squared is x over 3 to the third. So it's essentially a reverse derivative.
First derivative. Is there any case you need to use the chain rule for antiderivatives?
I don't believe so, no. Not in the same sense.
So for example, like, so what I explained, like chain rule, we peel off the onion layers. Is there any chance to peeling off the onion layers from core or center? Like,
to be honest, I'm completely blanking right now. I don't think so.
that's not possible. I mean,
Yeah, there is. I just forget what it is. What it's called.
there is some method to use that.
Yeah, there is methods involving integrals to do that.
How's 1C?
1C is very difficult.
Very difficult. Do you
Yeah.
guys have to do like derivatives?
We sometimes have to do derivatives, but mostly we have to do integrals.
Integrals.
Interderivatives, yeah.
Still have like in integrals like same concept in like chain rule?
Yeah. There are similar formulas, yes.
Can you share me like a little bit about the integrals and 1C?
Sure. They're not too complicated. They mostly follow basic formats, but let me just look up one for you. So there's a lot of memorization involved usually. For example, if you do term 1 times term 2, it would become the antiderivative of the first term times the derivative of the second term plus the antiderivative of the second term times the derivative of the first term.
So that's how you find the integral.
The integral, yes.
That's very interesting. It's just switch. Oh, but it's pretty similar like a chain rule concept.
It's pretty similar, yes.
I see. But it's a plus, right? But
Yeah.
in chain rule, there's like you have to multiply it.
Yeah.
I see. Thanks for your time, Clayton, and thanks for talking with me.
Of course.
Really appreciate your time. And
Yes, you too.
thank you.